Now, last episode we ended it on just the notation here, which you're familiar with a lot of this notation. And again, you can pause the video if you like and read through this, take some notes on it if you need to, or you can just skip ahead. So let's take a look at now how actually we create a confidence interval. Well, when you're looking at creating an interval that estimates the population mean, we call that a one sample t-interval, okay? And when the conditions are met, those conditions were, again, we're dealing with a simple random sample, that's our sampling process, and either the population we draw the sample from is normal, or if it's not normal, or we don't know what shape it is, then our sample size is greater than or equal to 30, we can construct a confidence interval using this formula right here. Now, it looks kind of ugly, but really it's easy to use. So, what does everything mean here? Well, we're going to start with our point estimate, which is our sample mean that we get from our sample. We're going to add and subtract from that our critical t-value. This again is the critical value. Now don't worry about the alpha divided by 2. Just all that's basically saying is that we're taking our alpha, which is again, that's the complement to our level of confidence, and we're splitting that amongst our two tails, and I'll show you that here when we do an example. We're going to multiply that times our standard error, which our standard error, again, ladies and gentlemen, is the sample standard deviation divided by the square root of the sample size. So, we're going to do that, ladies and gentlemen. That should give us our lower limit and our upper confidence limit and create an interval for which we feel the population mean falls between. Now, I'm going to show you a little something here. I'm going to extend this. But basically what this interval is, we're at the center of it is going to be our population, or excuse me, our sample mean. And then what we're going to do is we're going to set up an interval which extends between two values. We call this our lower confidence limit, and we call this our upper confidence limit. Now, how do we get to those values? Well, this distance right here, which is the same on both sides of the sample mean, that's basically your critical value times your standard error. Same thing over here. That's basically your critical t-value times your standard error. That's going to be the same because, again, the mean, the sample mean is exactly in the middle of your upper and lower limits. So if you take your mean minus this value, you get your lower limit. If you take your mean, add this value, you get your upper limit. Okay. Now, the only other thing I want to come up with or tell you about is this distance right here from each limit to the sample mean is also called the margin of error, and it's abbreviated by ME. Okay? So this is called the margin of error. And it's abbreviated ME. So basically, what we're saying is your margin of error is equal to your critical value times your standard error. So if I don't want to, basically right here, ladies and gentlemen, this right here, what you're adding and subtracting from your sample mean, that's called your margin of error. Okay? I wanted to make sure everybody understood that. So, again, you can stop, rewind, look over this again if you need to. Now, there's a lot of different ways to write a confidence interval, and here's how we're going to write it. We're going to write, ladies and gentlemen, we're going to put the population parameter we're estimating, the mean, we're going to put that in the middle. Okay? This will be right here our lower confidence limit. This will be our upper confidence limit. So in other words, you're going to have a value less than the population mean, less than your upper value. And as we do an example, I'll show you this. Now there's other ways that people write it. They write it like this, write it like this. They write it as an ordered pair basically, and I don't like that because you don't know what your parameter is. So what we're going to do is we're going to use the notation that I have on this very first example. Now, some round-off rules. And again, just as in when we had class, I'm not too concerned about this, but you may have some professors at college that are. But basically you round your upper and lower confidence limits to one place past what the original data set was. So if your original data set was whole numbers.
Any staff members that want breakfast or lunches, please come to the lights room. Please come to the lights room for breakfast or lunches. Thank you.
All right, so when I'm done here, I'm gonna go get some lunch. But, ladies and gentlemen, again, what I'm saying is if you're dealing with.
Lunches for your children, not for you, for your children.
All right, so again, I guess I'm not going to get lunch. But basically what we're saying is that if your original data value was whole numbers, then our confidence interval limits will be to the first decimal place. However, if you're given the original summary statistics, you don't have the original data, all you have is the sample mean, sample standard deviation, sample size, then we just round our confidence limits to the same number of decimal places as our sample summary statistics. Now, what we're going to do in the next episode, which would be probably the last of the notes before we get to examples, is just again, I want you to understand what an actual confidence interval means. So we're going to look at some graphs in order to be able to do that. It shouldn't take too long, but again, that'll be the last video before we look at some examples.